Alright, we're going to download the necessary software for 3D printing. The first thing we're going to need is Slicer. So if you go to Google and type in SLIC3R, it should lead you over to this website. You'll go to download now. You'll choose the operating system. Go ahead and click on it. I just downloaded this, so I'm going to go over here. This is Firefox, by the way. So I'm going to click on the magnifying glass. I'm going to right click on this and open. And then drag this to my applications. I'm going to have this that pops up. I'm going to replace it. And now underneath the Launchpad, I should have Slicer installed. Alright, the next thing we're going to do is go over to Blender. So blender.org. You'll go to download. And actually I want not the 2.8 yet. I really want to train you at 2.79. So looking for Blender 2.79. Alright. It says your old files are safe, blah blah blah, available for download. Actually I want to click on that. Go to 2.79 here. And you'll see that there's 2.79, there's 2.79a. You want the 2.79b. So let's see if I can make that bigger so you can see it. That one. Okay, let's save that. Alright, when Blender gets done downloading, just click on it. Right click on it, open. And drag this to your applications folder. You should now have, under Launchpad, the ability to launch Blender. Alright, you probably have this document. It has a link on it. So click on the link. If not, it's probably in the description. Right click here. Download. Now this might take a while to download. And when you are done, just make sure that you keep up on it. There's probably going to be a link here when it's done zipping. That's what you need to download. Alright, so now in your downloads folder, you should have this new zip. You right click on it and hit open. This will unzip it to your hard drive, and it should be this nice, neat underscore 3D programs. I would move this to your desktop. Now, the reason the underscore is there is because it floats to the top of all applications. In it, I have NetFab free. This moves over to your applications folder. I'm going to replace it. Alright, so there we go. Now, if I installed correctly, you should be able to go to Launchpad, and now you have a NetFab free icon. Alright, so let's review. I now have a NetFab free. I should be able to click it and it launches. If it pops up with this, you must go to Applications, right click, Open. Open. Once you do that once, you don't have to ever do it again. Slicer, you should be right clicking on it and open. This is the NetFab one, so I go to I accept terms and usage and later. And last but not least, Blender. You have to go to Blender 2.79. You can see I have very many of these things. So 2.79, right click, open. Alright, so just make sure they all open and then move on to the next part.
Alright, the next thing you need to do is identify which printer it is. So this number could change throughout the years, but for right now this is the number for this printer. Again, make sure that you are looking above the printer to see what number it is.
Alright, so you can get to the printer by typing that number, 10.223.7.237. And the login is other for this one. So if I was to open up a new window, it would ask me to log in, but yeah, the username and password is other. So what you do is, first off, go to Control, and you can see that's the printer that I was just at, and I can click this arrow and it will identify that it is connected. If it is not connected, it's because it's got right here, connect. Okay. So sometimes you'll have to press connect to get to it, and you can clearly move it. Good job. Alright, I'm going to raise it up in the air just a little bit. Two clicks, that's all it takes. Then I'm going to go over to temperature and the bed. They have a tool in the bed. This should give you in Fahrenheit, so I'm going to drop this down to ABS is the type of plastic we got. Okay. And then go ahead and hit the check. Now what you'll do is see this red line, it's going to climb up to this red line. And when this red line meets this red line, we are ready to go out to the printer and just kind of check the filament, make sure it's loaded correctly, make sure that everything is clean, and I'll show you that as soon as this heats up.
We are also able to log in to the printer using our cell phone. So it might be a little easier for you, because that way you can go out there with your cell phone and run the printer. So I'm typing the same number, 10.223.7.2. It's going to come in with the other. And here we are, same thing. Now notice that it's already in a connection state because I already connected to it. See? Under control, whoop, I can clearly see everything. These things right here, just mark read on them. And now, yes, I can move this. Yep, moved it. Good. I can check the status of the temperature. And you can see that the red line is close to that. So if I was to take this out, I could work on the printer at the same time and be on the cell phone. Pretty sweet, right? Okay. Alright, with it connected on my cell phone, I'm going to now run a check on the system. So if the tip is heated up all the way, I should be able to go over to control on the cell phone, and you see extrude. Okay, I'm going to hit extrude, and what extrude should do is extrude out some plastic, and you can see that nothing is happening. Okay. Nope. Okay, good. This gives me the option to go ahead and repair it. So the first thing you need to do is kind of remove the goober that's at the end of the tip. Okay. Remove the goober. And do this with cutters. And do not mar the tip. In other words, like there's a little tiny hole here at the end of the tip, and you do not want to ever use sandpaper on it or ever scratch it. So you want to do that very gently. Also, you could put in a larger amount here. Let's say I put 20 millimeters on the extrude and then hit extrude. Okay, still nothing. Good. Alright, so this is a bird beak, it looks like. You can see that it has a hinge right here. I'm going to lift up on the bird beak, and the whole thing goes back. Be very careful with this section because it is very fragile. So you want to, this is on a hinge. This goes forward, and you can see this orange filament. I'm going to press down a little bit, and you can feel it melt. In fact, if I press down hard enough, you see how it oozes out? This is a great sign. Okay? So what I'm going to do is press down on it, and then pull it all the way out. Okay? That's how you remove filament. And what I'm looking at is in here, there's a little wheel. See the little wheel? I'm going to hit extrude on my phone. And see how it moves. Okay? You notice how dirty that wheel is. It's pretty bad. So that needs to be cleaned. And you can clean it in two different ways. I like only one way. One way is a toothbrush, okay? The other way is using this Dremel, okay? And if you use a Dremel, please have your hair tied in the back of your head and safety glasses on, okay? It doesn't take much. In fact, you could turn this down to like 5, and you see how it has a spinning wheel. Again, hair turned back, tied back, and safety glasses on. And you just, it's kind of like brushing your teeth. And then you extrude it. Extrude it. And basically what you're doing is just extruding it going all the way around. You can type in like 120 millimeters extrude and just have it rotate while you do it. So this is the worst case scenario. And if you're scared about doing this, just use a toothbrush. And how you turn this off is just like that. So I would rather, as an instructor, have you use a toothbrush for it. But, and if you're scared about if it's like really dirty, you're feeling brave, go ahead and do this method. You're not going to hurt anything, but I prefer a toothbrush. Alright, so what we do is now cut the filament so it's flush with a pair of cutters. same cutters that you saw before that I cut the goober off with. And try to do this with one hand, so there we go. So it feeds in back of this rail, just like that, and then down into the 3D printer head. And the light twist like this will make it so it falls into an internal tube, and I should press down and you can see that it is in fact oozing out. In fact, it oozes out a lot better now because the temperature is higher. I'm going to close this. Notice how it's flush. There's no like little, this goes flush against there. This little bearing goes up against that. Okay, cool. The little bird beak goes in front of everything, falls into the channel, and I should be able to push down on the bird beak with very little force. Okay, sweet. Now that I have all that done, I should be able to go on my phone and hit extrude with 120 millimeters. And voila! It now extrudes. So this is a great sign. It means that we can go to the next phase of the test. In fact, that's how you change out different colors too. If you ever need to change out the color, you just remove this clip, remove the bearing, and there's a bearing on the other side. Put a different color in and put the bearing back, and put the clip back. Easy as that. Alright, now that we know we have an extrusion, I'm going to lightly sand, very lightly sand, with this really heavy duty grit paper. I'm exerting no force whatsoever. I'm just kind of dragging it across the surface. Blow off the dust. And spray it with hairspray until it's glossy. The hairspray acts as a covalent bond. In the hairspray itself, along with many ingredients that should never be sprayed on the human body, is acetone. Right? Nice. So the acetone and the acetone form a covalent bond together, making it stick to the plate. Cool. So let's go on to the next step.
Alright, so I'm going to switch over to the software because it's just easier to see without a jerky camera. Mark is red on all those. What we're going to do now is make sure that it's connected, just like always. Connected, yep, I can move, yep. So I ran through all the tests, I got an extrusion, and now it's time to run the test square. So you go down to test square, and there's a little icon right here. It's called print and test. Load and print. So I'm going to hit load and print. When I do that, you'll notice that there should be a few things that happen. If it doesn't, like I don't see any numbers changing whatsoever here, just make sure you do a refresh list and then click on again. So this time I see that this has changed, which is good. I see my extruder has dipped down in a little bit of temperature, so this has got to come back up. So when I hit print, the first thing that will heat now is the bed. After the bed reaches 80 degrees Celsius, it will then click back onto the tool and then heat that up. Okay, so together they will then start printing. And you know, it'll give you approximately how long it's going to take. You can keep watching over the temperature to see if this line leads this line. You can read these to check to see where the status is. Some things, here's G-code viewer. You can see how the layers are going to be put out. In this case, there's only like 4 or 5 layers. 7 layers right there. But once you hit that print, you have very little control. You notice I can't make it move anymore. If I ever want to cancel it, I could cancel it here. If I want to cool it down, I can hit disconnect and connect. You can see now that the printer has heated to the correct temperature. It is now going into its initialization phase of centering itself on the first vector of the platter. In this case, right about there. That little goober's not going to hurt it at all. It'll be fine. Now you'll see that this tip is starting to climb up. Here's the temperature of the tip. It needs to get up to 230 degrees Celsius in this case before it'll start going. Alright, so you can see the printer, it's going, and this first test is to test the leveling of the bed. You should see a line going all the way around and then another line going around. You should see this plastic sticking to the bed. Okay? If you don't see these lines, you need to repeat the extruder process to get that cleared out, because it should be extruding the plastic onto the bed. But another thing is, it could be the fact that somebody messed with some of the settings over here, making the bed unaligned. It happens from time to time. Please don't ever change the alignment on a machine. That takes a very long time of knowing how to realign a 3D printer. If you're not seeing it extrude the plastic out, come see the instructor, and we can look at it to see if it is in fact an unalignment issue. You can tell that because it will be almost scraping against the platter rather than printing. Alright, once this test is done, we can go on to the next phase. So just let it print, and then we can run an actual model on it.
Alright, so what you should get is a piece of plastic like this, and you can see that the print quality is rather good because it's nice and flat, it's smooth, okay? It's very durable because it's made out of ABS plastic. So if you're getting this quality on the test, then you can proceed to the next stage of the video, which is taking a model and ripping it down to G-code in order to print it.
Alright, for our first model, we're going to start out with something super simple that you're already used to, and then you can make it as complex as you want later on. So in Illustrator, make a document that's 8.5 by 11, and let's lay out an oval. Okay. And we will put a letter inside the oval. We'll put the letter T. Make the letter T big. Alright, perfect. Now, the T is made out of, the reason I'm using a font is because it's not made out of curves, and we have to convert that over. So in order to convert it over, we go to Object, Expand, and hit OK. Now it's made out of curves. And if you go to View, Outline, you can see what the curve looks like. Alright, so curve, curve. So what you do is you grab all of this and you save as SVG. I'm going to put a new folder on my desktop called 3D. And we'll call this example. And hit OK. Alright, so that's the first step. Again, you can get more complex later. This is just an example. Alright, we're going to start by configuring Blender. Okay, so open Blender and go File, User Preferences, and here it says Welsh keyboard. We're going to actually hit the import key configuration, and one of the things that you were instructed to download was the Welsh keyboard. So you go to the folder, and somewhere on your hard drive, for mine, there it is, and hit import key configuration. And then make sure you hit save user settings. Alright. So anytime you open up the program and it acts a little wonky, go to user preferences, go to input, make sure this is in there. Okay? Alright, that's how you configure Blender. Alright, now we import our SVG, which is a scalable vector graphic. And in this case I have it right here. Import. Now you're not going to see it because it's really small, and you use the wheel mouse to zoom in. Okay? You should have two things. You should have the letter T, and you should have this round circle. Alright. Now you just click on them and move them up and down using this blue arrow. Okay. Little heads up, 1 on the keyboard on the number pad, 3, 7. 7 is probably the most useful one because it's in a top view and you can align your stuff. Okay. So just practice that. 1, 3, 7 on the number pad. Alright, so that's how you get your scalable vector graphic into the program. Another thing that makes life easy is Z on the keyboard. Z allows you to see just the actual thing that you made without the material. So I could maybe move this to the center. Move this to the center. Right here it says top perspective. When you hit 5 on the keypad, it goes into orthographic. So make sure that you practice using Z on the keyboard, and also make sure that you hit 5 on the number pad so it goes into orthographic view. And orthographic is just a camera without a lens, so there's no distortion. Alright, to go back into 3D, you hold Alt, left mouse button. Just practice Alt, left mouse button for a second. Now Alt, middle mouse button allows you to pan, it's called. And Alt, right mouse button allows you to zoom in and out. So take a second to orient yourself with the navigation before we begin. Alright, so hit Z on the keyboard. We can go back to material view. What we're going to do is get rid of this black material because it's really hard to see. In order to do that, you just page over to this little ball over here and you get rid of this X. Just click it and do that for the T too. Okay? A lot easier. If you're not seeing this window, it's N on the keyboard. N is in Nancy. And let's turn on texture solid. That'll come in handy later. And then we're going to take this is just a curve. We're going to turn it into 3D. Okay? Alright, so not much movement here. You're just, highlighting things with the left mouse button at this point. So highlight this piece. Object. Convert to. Mesh from curve. Okay. So it didn't look like much happened, but what we're going to do is go over to the box and click on wire. And you can see now instead of curves, it's going to be made out of little wires. Notice this one, if I turn on wire, doesn't have the little lines. Okay? So anytime you have a curve, you just have to convert it to a mesh. Just like that. So remember that it can be any shape in Illustrator whatsoever. There's no rules. Alright, now we have to give it thickness. So that's the next part. Alright, in order to go to the next step, we have to go into edit mode. We're going to have to turn on faces, this little guy right here. Highlight a face and hit L on the keyboard. L is in Larry. Alright, now here's the tricky one. Okay. Control E. Now when you hit Control E, don't touch the mouse right now, like for a second. Just hit Control E without the mouse. And then ever so slightly move the mouse up. And you can see I am now giving this depth. Huh? Alright, pretty sweet, right? So notice I can't highlight the T because it's a different object, but this one now has depth. If you very carefully hold Alt and left mouse, you can like kind of mouse around in the scene. You can see the depth. Alright, let's go to object mode. Let's do that to the T. Again, click on the other, go to edit, go to faces, highlight a face with the left mouse button, hit L on the keyboard, L is in Larry, Control E, and then move your mouse up carefully. Nice. So now you have Object 1 and Object 2. Go back to Object Mode. And you can move, again, this is the wheel mouse. You can move this one down and you can see that it cuts into the shape. You can see it in that view. You can go to 7 on the keyboard. You can see it in this view. You can hit Z on the keyboard and see it in this view, which is a little easier sometimes to center it. Let's say I want to center this. Z on the keyboard. You can see if I mouse to right about here, this object and this object aren't really touching yet. You notice I can like make this touch the object just by going down only in the blue arrow down. So now this object and this object are embedded. Okay. Now we're going to look at combining these two objects together in the next part. Alright, so before we combine these together, if you want this piece to be thicker, you could go to scale and scale it up. Okay, let's say I wanted to be thicker. And I only use the blue line. This one would be move. I can move it. I can make it crash into the object. As long as this object and this object is touching, you can see where I'm lowering it down and that white disappears, and that indicates that here's this line. If you go down, white disappears into it. That indicates it is touching. Alright, cool. So this object right here and this object have names. In this case, if you go to the little brown box, the first object, let's call it something. Let's call it oval. And this one, we'll click on it and call it T. Alright. So let's go to the oval and go to the wrench. Let's go here, add modifier. Let's go to Boolean. And what I want to do is create a union. I got this one highlighted. I want to call it a union with T. So just select the other line or the other shape, which in this case I called it T. And then hit apply. So now these two objects are absolutely one with each other. They are combined and 3D printable. Alright, now I'm going to use that Boolean again. I want to show you a little trick with Boolean, this time with a 3D shape. So this step was just combining shapes to give it depth, and then the next part I'm going to show you how to like put a hole here. Alright, so I have my piece. I like it. It's combined. I can actually move it, and you can see that there's an extra T in here. I'm just going to get rid of that by hitting delete on the keyboard and going to delete. I need to now take this piece and make it into a real world measurement. Okay? So the first thing I do is object, apply, rotation and scale. Then object, transform, origin to geometry. That moves this thing closer to the origin. And now, again, if you don't have this on, this is N on the keyboard to bring up this menu. This thing is really small. I mean, like even small by small standards. We're going to make it a little bit bigger. We're going to make it about keychain big. Okay, keychains are about 2 inches. So there's X, Y, and Z. Y is green, X is red, Z is blue. Y is this way. Okay, so this is in millimeters. Alright, well, what is 2 inches in millimeters? You can use Google if you want. Doesn't matter to me. Just type in 2 millimeters. So it's around 50 millimeters. Nice. So let's go to Blender and go to our scale. And the white circle, go ahead and click on it, and as you're doing it, make sure you're watching the Y number. So I'm just making this bigger. See how small it is? Let's read it. So right there is 50 millimeters. Big difference, right? So that's scaling it to real world size. And now we can drill a hole in it. Alright, in order to drill a hole through a 3D object, we're going to need a drill bit. In this case, you could just go to Add, Mesh, Cylinder. Okay, really hard to see that cylinder because it's in the middle of things. So a good way to see that is go over to the little words over here, and you can see that you can highlight cylinder, or you can highlight the oval. I'm going to highlight cylinder, move this way by using the move tool. So So if you're on scale, go to move, and then you can move the cylinder. Alright, we need to make a hole that will encompass those little rings that we use for keychains. The rings are exactly 1/16 inch in diameter. Okay, we need to figure out what that is in millimeters. Alright, easy. Get out a calculator and take 1 divided by 16. I get 0.0625. If you go to Google, you can type in 0.0625 and you have 1.578 millimeters. Well, the good news is in Blender, this thing is 2 millimeters. So we're going to actually use a 2 millimeter to use it as a drill bit. We don't even have to resize it width-wise. We could do that though. How about let's resize it this way? Well, we could, and that's Z. See the blue arrow? Okay. So I could type in 20 here, and that will make it a little bit taller. If you hit 7 on the keyboard, the number pad, Z, I can then put this where I need it to go. Let's say right about here. Hit Z again, Alt left mouse, and now I have this. Alright, this piece, we always have to clean it up before we drill. So how you clean something up is you apply rotation scale, and you transform origin to geometry. It doesn't look like it did much, but it actually did a lot. Alright, now that we have our object, we have our drill, let's go over to the box and we call this drill. And this is called oval. So oval, go to the wrench, do a Boolean. This time I want to use a difference using drill and hit apply. What that did is now if I take the drill bit out of the way, I am left with a hole for a keychain. Ooh. I can now get rid of the drill. Delete that out. And now we have a very simple 3D object that we could print that is based on real life. And it's got a flat bottom. It's a good example piece. You can get as complex as you want. With the letter, you can make, all kinds of crazy things for this example, but this would be as easy as I can get to illustrate how it works. I leave it up to the other type of student that needs, like greater detail, and use this example for it. Alright, again, let's clean up the piece. Apply rotation scale, and transform origin to geometry. Alright, it is now ready to export. Alright, we should save it. Save as. I should have showed you how to save a long time ago, but that's okay. We'll get there. We're going to save it as a Blender file. So save as Blender file. Alright, and then we're also going to export using STL. They have a little checkbox. Uncheck this please, selection only, because I should have that selected, by the way. So select object, export, still, select that. We'll call this keychain. and hit export still. Alright, now we're going to clean up the geometry using NetFab. Okay, so in order to do that, you look for NetFab. You should have it installed. I accept the terms of usage. Wait 6 seconds or something like that. Let's go later. Alright, here we're going to go project, open. I'm going to go to the desktop and choose keychain. There it is. I'm going to hit the first aid button, repair. I'm going to do an automatic repair, execute, apply repair, remove old part. That's it. That's how we clean that up. So to export it back, I go right click, export part, still. Alright, this is a very important part. Pause your brain. I need to uncheck desktop and go to applications for a second, and then go back to desktop. If you do not do that step, the program will crash. Okay? I don't know why. So let's save. And now I have another file on my desktop called repaired. Alright, so that's how you clean up geometry. Now we have to make it G-code. Alright, to make G-code, we just go to Launchpad and we'll look for a program called Slicer that you installed earlier. We have to import the configuration. So file, load configuration, and this is where the file Spider-Man comes in. So this is saved on my desktop from earlier. In the video I showed, you know, like the installing of things. Without this file, it will not print correctly, and this is probably the step that the students miss the most, is Spider-Man, because they get in a hurry and they forget. So Spider-Man must be loaded first. And then I'm going to hit add. Then I'm going to make sure I use the repaired one, keychain repaired. This is out of NetFab. And there it is. Alright, not much to do here, really. I mean, I could just export G-code. And I'll export if I just hit save. And now that is ready to print. I'm going to actually load it to a 3D printer and show you how that works. Okay, so here we have a 3D printer. It looks like the lights got turned off in that room. This is the yellow printer. I don't know if it's, yeah, it looks like it's working good because I'm connected to it. I already went in there and took and put hairspray on the bed, and I automatically went in there and did the hairspray. I made sure that I had a good feed, everything else. So this is, I ran through the debugging process already on this printer. Okay, so make sure that you do that first. If you're unsure, it's the same process as in the earlier parts of this video where I went through printing the test square. The only thing different now is when you hit upload, you can choose your keychain. Now, if you can imagine, there's going to be 40 students that all have keychains. Okay, you might want to put your name here, you know, rename this file as like first name, last name, or something like that, because there's going to be 100 keychains on this thing. Just never delete test square if you could. Okay, please don't do that. This you can, but these are going to get deleted. Just letting you know. Alright, it should be ready to print. Let's test a few things. The connection's on. I can move the arm. Good. Let's do keychain repaired print. Alright, let's go to temperature and make sure that temperature, yep, here's the blue one. It went up. That means the bed's going to heat up first. And I can see that blue line, see how it's going up. That means yes, I have a good connection. Yes, there is power going to the printer. There we go. Let's let it print. Alright, so this gives me an opportunity to show you what to do if things go bad. And we are going to, I'm going to cover how to do many in the next little section here. So if you're interested in making lots of these, or maybe even 2 of them or 3 of them, watch the rest of the video. But this is problem solving. So for example, I have this printer right here. It's just printing a bunch of crap. So what do I do? Like, how do I stop it? Well, you can go over to cancel and yes, but you're going to see that sometimes that doesn't work as fast as disconnect, connect. Okay, this is a little bit faster way to do that. Alright, in order to fix this, I need to go clean this hot mess up. Well, I'm going to raise the bed, or raise the print head just a little bit, and then go clean off the palette. Now, the yellow printer is probably the most schizophrenic one. If you want really good fast results, the green one works really good and the blue one works really good. So I wanted to run this one on the yellow one just to kind of show you the problem solving, if that makes sense. I'm going to clean this up and rerun it, but you can see that my one that's printing 3 of them is working quite well. So if you're interested in the multiple, go ahead, and not to steer clear from the yellow one, but eventually it'll get there. But the blue one and the green one are very stable when it comes down to it. Alright, sweet. So that's problem solving. I'm going to go clean up this mess over here. Alright, if you want to see how to print many of them, please continue to watch the video. If you don't, you can just collect your 3D piece when it's done printing. So this part of the video is to explain how you do many, which isn't really hard, so you might as well just watch it anyway. So in Slicer, I have one, and I'm going to go into 2D view. Okay, I'm going to hit, after 2D view, select the object and say more. And now I got 2, and I could do 3 if I wanted to, or fewer. Okay. In fact, when you do fewer, you can see that now there is a space between the 2, and sometimes that's really good. You'll see why later on. Sometimes it might get too hot for objects. So this is a button that allows you to do many. Alright, now I'll export the G code and say 3. So indicating that there is 3 in this one. This is the one that is printing right now. Well, I have 3 3D printers, so I could just go to the other one. Oh, I think that's 7. My bad. There it is. So here's a different 3D printer. I'm going to send the other G code to it. Again, this has been prepped. It's been sanded down. It's been everything. I can now go to upload and upload the 3 to it. And hit print. So now I can watch this one print, and I can print to this one too. Yay. Mark read. So that's how you make many of them. You'll notice you have a lot of options in here. You have scaling if you want. Here's, you know, like how the size of it. If you ever wanted to size it up, you can always size it up in here. The preferred status for sizing, though, is Blender. You would have to go back a few steps because you have very, very large amounts of control over scaling here. And this is a real world number where if you went into here, you have, you'll notice it's a percentage, okay? And a percentage is really hard to kind of calculate. If I wanted to say like 31 millimeters, what percentage would that be? All right, so Blender would be the preferred state for making things bigger and smaller. And then you would, of course, have to take it to NetFab, clean it up, then bring it back. So it's a pretty good grind of the workflow, but if you like 3D printing, hey, it's worth it. All right, so that is how you do that.